Hi, everyone. My name is Simranjit Bhella, and I'm here with my team to introduce you to our capstone project, What Would Portland Do? This project was sponsored by our local Portland artist, Stephen Oakes. All right, so let's hop right into an overview of what the project's all about. So, What Would Portland Do, also known as WWPD.AI, is an interactive pixel art simulation with large language model controlled agents that generate novel ideas. This project aims to be a platform for entertainment, learning, and exploration of these LLMs behaving in an agent-based simulated environment. Now let's move on to Adam for a more in-depth demo of our project.
My name is Adam Hiatt, and I'll be giving a quick demo of the What Would Portland Do Capstone project. So the idea behind our Capstone project was to create a simulacrum of different characters' experience in Portland. So you can see on our interface here, we have different Portland landmarks. We have Voodoo Donuts, we have the food carts, we have Nike over here, and a number of other Portland-themed locations. So we created all of this using artificial intelligence agents to guide the characters through a moment that they experience together. This is all done using the Hugging Face hosted inference API, where they have a variety of open source models available to use for free, as well as some premium models. So before I dive into the moment, let me show you around the interface. If we open up the side panel here, you see we have an interface viewer. If we toggle this will let you either view moments, which nothing's here yet since we haven't started one, or you can directly interact with one of the agents by clicking on them and typing in a message. Going back to the interface, we have a play moment where you can select a moment. We have some that are out of the box, and then you can also come to edit moment and create your own moment. In addition to creating your own moment, you can come into some of the out-of-box moments and update those yourself. Another really cool feature, given that we're using an API that has access to thousands of open source models, we've picked a few good ones and allow the user to change which model they'd like to use here. We found best results with the Mixtral model, and then we also have the Stability XL model for text-to-image generation. Last thing in the interface is the character cards. So you can come in here, you can read about the character, their specialty, their personality, and select which ones you'd like in the simulation. We'll just go with the default ones for the purpose of this demo. So let's start a moment. Let's come over to play moments and do keep Portland weird. So in this, they walk through actually, let me show you. Yeah, so in this moment, they're going on an adventure in Portland with their friends. They need to plan a trip in detail and consider Portland's eccentric character. And then at the end of the moment, which we'll show, it has them describe their favorite moments from the trip, given the context that they have just returned back from Portland. We can see here, these agents are attending the moments, and they are thinking about their trip. And these agents down here, they're not actually attending the moment, and they are at the Coffin Club. So their actions are denoted by a skull, and they're looking for something there. This agent, there's two overlapping here, but all the agents that aren't attending also have emojis representing what they're doing. Now that these two agents have finished their ideas, it gives emojis based off of their idea. So let's look into the moment. The primary agent, her initial idea, she starts by thinking off about what kind of accommodations she would choose, what activities she would plan, where would she eat. She likes local farm-to-table restaurants, which Portland is great for. And then the rest of the agents start planning it out as well. So one thing to notice is that the agents are given their personality and career when they're thinking about what to do in the moment. So as a strategic thinker, they're recommending doing a lot of research and comparing different boutique hotels in Portland to find one that aligns with their desired experience and budget. We also have a bit of image generation using the Stability XL model. Looks like they're generating an image of Portland. It's based off of this text here. And we have all the agents that are attending the discussion doing the same thing. And then at the end, based off of all of these inputs from all of the agent's friends, she comes up with a final idea. And they're talking about their favorite moments from the trip, just like we intended. So I'll let you pause through the recording to look through some of this output if you'd like. But that is the gist of the moment. And we also have a bit of a slideshow that they put together based off of the moment that they experienced together. So here in a moment, the agents will disperse and go about their activities, just like you see these agents down here doing activities that aren't related to the moment. But I'd like to show you one last feature. So you can directly talk to the model. So let's do what's the weirdest part about Portland. Give it a moment to respond. Great. So we ask Abigail, who is currently the primary agent, and they give a detailed response based off of their personality. It was a pretty interesting project to work on. One thing to keep in mind is that all these moments can be custom tailored using the interface, but also every user's moment is going to be different. Since we're using artificial intelligence models, which are non-deterministic, these responses are going to be different every single time. It also, given that limitation, or that also provides a limitation because we can't 100% control the output of the model. So users may get weird output sometimes, but overall the responses seem to be good, especially when using the Mixtral model. So that's what I have for you today. I hope you enjoyed the presentation and like our project. Thank you.
Hello, my name is Thomas Brooks, and I will be going over the features of this project. The first feature and the main feature really is the agents. So by leveraging large language models, we are able to create these agents, which are able to take on distinct personalities, perform actions, and maneuver around the map to perform said actions or traverse to a meeting place or to other agents. Now, agents really revolve around their personas. They all have unique ages, careers, and personalities. These personas are then used in the model input, which are able to prompt various open source LLMs with their personas to create believable moment responses and messages based on that persona. Agents also perform actions based on their persona and display emojis corresponding to that action. So if a agent is a computer scientist, they might spend some time programming, or if they're a project manager, they might spend some time consulting with a client. The agents also use pathfinding, which is an A-star pathfinding algorithm to just traverse to a destination in the map in the shortest route possible. And there's also an agent editor, which allows users to either edit original other agents or create their own ones as well. As mentioned previously, moments are also in this and are a pretty big part of the project as well. Agents are able to play out these moments. They all start with a primary agent getting an idea and then talking to other agents based on that idea to gather other dialogue, and then it ends in a final presentation from the primary agent. As mentioned before, again, the agents use large language models to get prompted for this moment based on the idea that has been given, and other agents and the primary agent all adhere to their personas with the responses that they give for the moment. The agents also use text to image to generate images based on the response that they give, which are then used in the final presentation by the primary agent. There's also the interface, which allows users to view messages concurrently as the moment is happening, and also being able to just directly message an agent using a selection of large language models so that the agent will respond to the user's message in the persona that has been defined. So there we are, the message input and the moment input, which I just discussed. There's also options to email and download a moment. So if a moment is really great and you really want to have a transcript of it, you can have it emailed to you or downloaded onto your system. And there's also a typewriter component in there, which rather than having all the text just show up on screen at once, it'll get typed out, which makes it a little bit more lifelike. There's also some future features that we wanted to add, but weren't able to with time constraints primarily. First is text-to-speech. This is one that we were trying to do for a good bit of the project, but weren't able to. The original model we were going to use was cross-prohibitive. Open source APIs were too limited or produced unreliable results, so it was scrapped. The project was also planned to be sourced on AWS as the domain, but with time constraints, we actually ended up hosting it on Vercel. And there was also going to be a lot of different styles of agent presentations. So rather than the presentation style where it's just the primary agent speaking with the slideshow, there was also going to be TED Talks, plays, parties, speeches and papers, but with time constraints, this was dropped.
Hi, my name is Todd Hickam, and I'm going to talk about the architecture of this application. The client application uses the React.js framework and a Vite bundler. On the back end for persistence, we have Firebase DB, and we have integrated AI models using the Hugging Face platform. The architecture itself is a direct reflection really on the difficulty that we had achieving live feedback for like modifications and changes made to the original Python code base. So the idea that we had was to come up with a more performant way of representing that original idea. And React.js is great. It also has modularity in mind. So our implementation tried to create that loose coupling of functional components, allowing the flexible and scalable control that would be necessary to evolve this project over time. Now, to achieve this and meet the sponsor's requirements required 4 specific blocks or focuses. The first one are global providers. And what a global provider is doing for us is maintaining a shared state. So as we push things to Firebase, we want to make sure that our global objects that are accessible throughout the tree are going to have the exact same state, as well as provide easy access to that state anywhere in the tree, rather than forcing an object down or passing it along by reference all the way down to some leaf node. This allows you to immediately gain access to that state. We also have flags that are global, and what that allows is to control the state view. And as it changes, we're also ensuring that things that are unnecessary at the time are no longer trying to render in the background. The second are components. The 2 primary components that we have are the game engine and the user interface. The game engine itself is handling agent actions and rendering those. So we have sprite images or PNGs, and those sprite images are 3 columns by 4 rows. At any given time, we have to make sure that that frame for its X and Y position in the game is being rendered correctly. React does a great job of ensuring that it is super fast at rendering those. And of course, with Firebase as a real-time database, allowing those dynamic changes to occur, we can also implement our moments, which are autonomous interactions by the agents in the game, and allow those interactions to be rendered through that game engine. Our interface is where the user is going to have a chance to interact with the AI model. And for those interactions, as well as updating, changing, or modifying any kind of a moment, the interface itself as a component is the second critical control unit to this entire application. What supports this are the modules or the functionality behind it. We have static pages such as personas or data that we, of course, when you first log in, we have to make sure that Firebase is loaded with some data. From there, the functionality, the control, the heart of the moments are in the modules. Those modules themselves combine to help or support, as they should, the components then that are at the heart of this application. Finally, the APIs, again, we are connecting to Hugging Face, integrating a large array of new AI models from text generation to text to image. And down the road, or what you might call a stretch goal, we want to integrate quite a few others, such as text to video, text to speech. And as these AI models are progressively evolving, I think Hugging Face platform is a great way or a great integration, really, for those that might want to take on this project and build something themselves. Firebase, I do believe, is a great real-time database. It's definitely supported this application in a way that it wouldn't be possible otherwise to have built. Finally, I want to hand this over to Andrew, who's going to explain the development process. Thank you.
Hello, my name is Andrew Bonham, and I will cover our development process. We decided to use an agile development method, meeting once weekly every Tuesday at 2 p.m. We worked in 1 to 2 week sprints for our assigned tasks. adding new tasks or re-evaluating the importance of a task every week. We met remotely via Zoom calls for our weekly meetings and used Jira as our scrum board for managing and assigning the tasks. The Agile development method allowed for adaptive planning and responding to any changes to the requirements. This proved especially helpful towards the end of the project. During the first quarter, we had spent 4 weeks conducting research exploring the Stanford Generative Agents project for potential integration. We quickly discovered that trying to adapt this project to meet the sponsor's specifications was not feasible. Because of this, the decision was made to shift the project specifications, leading to a strategic decision to pursue a new direction for the rest of the quarter. A game engine was built in React and utilized Hugging Face models to meet new specifications. Certain aspects of the new simulation for the project were not matching the sponsor's specifications. This led to a redesign during winter break and the first 2 weeks of winter quarter. The redesigned simulation allowed for multiple users to access independently while also introducing the newly made concept of moments. With project MVPs complete, we began the process of incorporating continuous sponsor feedback, successfully implementing stretch goals, cleaned the UI and codebase, had written documentation, and deployed on Vercel.
Hi everyone, this is Simranjit Bhella, back again to go over the team's responsibilities and contributions. So first up, going over the responsibilities, let's take a look at our work distribution. So within our team, we had work assigned based on individual availability and skill expertise. Taking a look at the availability alignment, we tried to balance workloads by considering each team member's schedule in order to ensure an efficient workflow. Then we also took a look at expertise utilization, where we tried to allocate tasks to capitalize on each member's expertise and to promote skill growth and specialization. And lastly, let's look at the adaptive tasking. An agile approach allowed for us to make flexible adjustments, aligning responsibilities with the evolving project landscape. All right, let's move on to contributions. First up, we have Todd Hickam, who designed the architecture, built the React game engine with the core components, set up the Firebase server, and deployed the project to Vercel. Next, we have Adam Hiatt, who researched the Hugging Face models, worked on prompt engineering, built a prompt testing tool, implemented agent actions, and implemented parallel queries. And then on to Thomas Brooks, who implemented the pathfinding algorithm, implemented version 2.0 of the map, and built the typewriter component. Up next is Juno Dunlap, who wrote documentation, including the README and GitHub wiki, and tested the program and reported bugs. Then on to Andrew Bonham, who refined the UI components to meet sponsor standards and worked on user input for moments. And finally, last but not least, we have Alec Diefenbaugh, who worked on prompt engineering, model research, refined prompting for moments to meet sponsor standards.
Hello, my name is Juno Dunlap. There were a few unexpected events that occurred during our development process. First was adapting the original concept to something we could achieve in a 2-term capstone. The original Stanford Generative Agents project done by Junsun Park was too complex for what we could accomplish in the time frame and had to cut down a lot of features. Next was our first iteration of the LLM show. It was originally designed to allow multiple users to control the same set of agents. However, with new specifications given, we could not accomplish this and had to rework a lot of the project. And finally, we had a large snow and ice storm that knocked out power to chunks of the city, closed campus, and introduced several delays in the second half of development. We were able to compensate for the delays and get our project back on track thanks to good communication between team members and excellent teamwork.
Hello, I am Alec Diefenbaugh, and I am a team member on the WWPD.AI team, and I'm going to be going over Part 6, Customer Feedback and Lessons Learned. And we'll start with a video from Stephen Oakes, the sponsor, with him giving his feedback.
I think you guys did an excellent job. With the amount of time that you have, the program that you've created is pretty exceptional. I think what could be improved in it is the interface. But that being said, there's a lot of stuff going on in this, and it was pretty great. I love the Capstone project, the Capstone program. It's always fun, and I think that it's really impressive to see how the students participate and what they create. And so, for me, this is a cutting edge project, cutting edge proof of concept, and the way that you guys attacked it and tried to produce the best possible thing you can with kind of just a amorphous idea is really impressive. And I think the team should pat themselves on the back. And I think that they probably gathered a lot of really amazing skills from this project.
Now I'll go over the next part of this section, which is lessons learned. Here are some of the lessons that we learned while working on this project. First, we learned the importance of flexibility and adaptability. This project reinforced the importance of being flexible and adaptable in response to evolving requirements and unexpected challenges in order to ensure smooth progress. Next, establishing guidelines for working within a shared repo was a crucial lesson learned. We learned that having guidelines help promote developer productivity as well as code quality. And the last lesson learned, this was a big one, was having fail-safes when working with AI. So LLMs and other AI models always have a chance to give you incorrect or strange responses. So making sure that your code continues to run despite these incorrect responses or issues is very important, so that your code doesn't crash and so it maintains its usability. Thank you.
Thank you everyone for watching the What Would Portland Do capstone presentation. If you'd like to give it a try for yourself, head on over to WWPD.AI.Vercel.app.